I need you to pay attention to this. We do have this test tomorrow. I need you to focus. Okay. So we're going to start with, if you have a situation where you have an exponential equation and you have to find out what the exponent is. Okay, the first thing we're going to do is get everything that's in front of it away from it. So I'm going to divide both these sides by 2. And I'm left with 3 to the x equals 4. Now, if I knew what if it was like 9, I know that x right away would just be 2, right? But this one's harder. I don't know what number I would have to take 2 to get 4. It's not a whole number or a natural number. So what I'm going to do, the way to undo exponentials. So the way to undo something that's being multiplied is you do what? So the way you undo exponentials is you take the log. So we have the base is 3, x equals 4, so I'm going to take log base 3 to the 3x equals log base 3 to the 4. Whatever I do to one side, I got to do to the other. Okay? Log base 3 to the 3 just gives me 1. So this gives me, by the power rule, I was able to bring that x in front.
So x equals 4.
Log base 3 to the 4. Now, some of you, your calculators are in test to press, or they will be for the final exam or for the SAT. So you need to know how to do change of base, because it will not do anything if it's in test to press that's not base 10. Therefore, we're going to do x equals log base 10 of 4 over log base 10 of 3. And you just stick that in your calculator. You'll get the same answer as if you do log base 3 of 4. But again, your base buttons besides base 10 might not work.
It doesn't say log.
So, right, because if it says just a log, we know it's in base 10. That's one of our rules. So x equals 1.26. I want to remind you guys that I am recording, but I still notice if you're on your phones or not. So if you could get off your phone, maybe turn them upside down so you could do this that I have in front of us. Okay, so number 2 is just a few more extra steps, but the same basic thing, and the extra steps I give you are basic Algebra 1 extra steps. The first thing I'm going to do is I'm going to subtract 5 from both sides. And I get negative 2 times 3 to the x plus 1 equals negative 18. Now I'm going to divide both sides by negative 2. And I'm going to get 3 to the x plus 1 equals 9. Okay? So now what you can't divide by 3. You've got an exponent you don't know. So what do we do to undo an exponent? Log. So we're going to take log base 3 of 3 to the x plus 1 equals log base 3 of 9. Log base 3 of 3, we can take the x plus 1, it goes to the front because of power rule. And then log base 3 of 3 just gives us 1. So we get x plus 1 equals log base 3 of 9. And then we're going to subtract the 1 from it. So we get x equals log base 3 of 9 minus 1. And then again, we can change this to change of base. We can use change of base to find it. Log base 10 of 9 over log base 10 of 3 minus 1. And we'll get our answer is x equals 1. Of this.
Yeah.
I'm going to try to get through it all, but we'll see how much time we have. Okay. So now I'm going to look at number 3. And I've got a log where I don't know what x is. Are the logs equal to each other? Okay, we can take both of these sides to exponentialize them to the 3, but it's just going to cancel them out anyway. So I'm just going to get x minus 1 equals 2x plus 4. And then we're going to solve for x. I'm going to subtract x from both sides. So negative 1 equals 1x plus 4. I'm going to subtract 4 from both sides, and negative 5 equals x. Now, I think I told you guys this earlier during your homework, but you cannot stick a negative number that will give you a negative answer for your a value for logs. It'll say no solution. So if you wrote either one of these, I don't think there is one on your test, but if you got a negative answer and wrote it down, or if you wrote no solution, I'd give you either one of those. Right. Okay, now we're going to go through and do number 4. I'm going to subtract 5 from both sides, and I get 2 log 3x minus 7 equals 9 minus 5 is 14. I'm going to divide both sides by 2. And I get log 3x minus 7 equals 7. So now I have a log. How do I undo logs? If I undo exponentials by taking a log, how do I undo logs? By an exponent, right? Does this log have a base next to it?
No.
So it must be base
10.
So I'm going to take both of these, times it by 10, and now they are an exponential. Okay? So this means that I'll end up having 3x minus 7 equals 1 million. Because 10 to the 7th is 1 million. Okay? So because the base of this log is 10, if I exponentialize it to 10, so if I take 10 to that whole thing, base 10 log to the 10th gives me 1. So it gets rid of all that, and I'm just left with 3x minus 7. Okay, no. Now I've got to add 7 to both sides, and I get 3x equals $1,007,000. And then I just got to divide it by 3. So I'm just going to leave it just like this instead of getting a weird decimal. All right. Let's look at number 5. Number 5, you're not going to get a number as your answer because it has that y in there. But what's nice about these is that it's all about showing your work because you won't get a number answer. So you can't just stick it into your calculator. You actually have to show all of them. And it's the process that really matters, not the answer. So we're looking at 5. No. So we're looking at 5. Y equals 3 log x minus 5. So the first thing I'm going to do is I'm going to get rid of this 5 by adding 5 to both sides. These cancel, and I'm left with y plus 5 equals 3 log x. So we're okay. It's the opposite of PEMDAS, right? First you get rid of all the addition and subtraction. Now we're going to get rid of all the multiplication and division. So what am I going to get rid of? 3. So I'm going to divide by 3. These cancel. And I'm left with y plus 5 over 3 equals log of x. How am I going to get rid of that log? Exponentialize. And what's the base of this one? 10. So I'm going to exponentialize. I don't know if that's a word, but I like it. So I'm going to get x equals 10 to the y plus 5 over 3, and that's my final answer. Where did you guys lose me? So you're okay with adding the 5,
Right.
dividing by 3?
Yep.
Then you exponentialize, which I don't know if it's a word, but when you have a log and you don't know what the number next to it is, and you have a variable.
Oh, I get it.
And then whatever, see how I use 10 here? I use that because that's what the base is for my log. Okay, let's do another one where my base of the log is not 10. So for number 7, I am going to solve for t. So the first thing I'm going to do is divide by 1,000.
5, on number 5, part of the log?
There's no negative 5.
Like,
No, it's not part of the log. It would be in parentheses if it was. That's a great question. If it's not in parentheses, I'm going to assume it just goes with that. If it was in parentheses, if it was x minus 5 in parentheses, like number 3 is, see, I knew that 1 was part of the log. This one's not in parentheses, so I'm assuming it's just at the end. Okay. So I get p over 1,000 equals 1.054 to the t. Okay? Now I'm stuck. How am I going to get rid of that t next to my 4? Log. Log base what? What's the base of this? Yeah, log 1.05 p over 1,000 equals log 1.05 times 1.05 4 to the t. Now I know this gives me 1, and the power rule makes the 4t go in front. So I'm going to get log 1.05 p over 1,000 equals 4t. And what's my last step? Divide by 4. So I get log 1.05 is my base of p over 1,000 all over 4 equals t. It's the opposite of PEMDAS. So when I look at this, is there anything being added or subtracted? No. Is there anything being multiplied or divided? Yes. So I do the opposite of multiplication. Next, I'm stuck because I can't get rid of 1.05 because it's taken to a power, 4 to the t. So I have to think about how am I going to find out what an unknown exponent is. That means I do a log. So I take the log of both sides, log, and I have to use the base that the base is at. So log 1.05 p over 1,000 equals log 1.05 times 1.05 4 to the t. Power rule makes 4 to the t come in front. Log of 1.05 times 1.05 is 1, so it's gone. And then I just got to divide by 4, and I have the correct answer. Yes? No. Because there's not one that hard on the test, and it confuses me because they both are I. One's I0 and one's I1, and I don't like it. I can if you want to, but there won't be. Yes? Who's asking? So look at your test review. There's some on there like it. I don't think any of them are unknowns where you would get an answer like this. You would get a number for all of them, I believe. Okay. All right. We're going to do a log transformation for this one. Y equals 5, 3 to the x, and we're going to solve for x. So what's the first step I have to take? Is there anything being added or subtracted to it?
No.
Is there anything being multiplied or divided by it?
Yes.
What?
5.
5. Divide by 5. We can't divide by 3, right? Because the 3 is taken to the x, so we can't use that. So we have y to the 5th equals 3 to the x. Now what do I use to find the unknown exponent? Log. Log base y3. Because that's what my base is at right here, right? Log base 3 to the 3x. I use the power rule to bring the x in front. Log base 3 of 3 gives me 1. Yep. Yep. Okay. Yeah, I would like you guys to try number 8. 10 is a trick problem, so I'd rather not do that. So why don't you guys try number 8 all on your own, and then we'll go over the problem together. Yeah, I'm going to give you like 3 minutes. Yes. So for the test tomorrow, what I'm going to do is I'm going to read you the answers to all of the review. I'm going to have numbers, whatever the numbers are, through 17 or whatever they are, on the board. And when you come in, your warm-up is going to be to mark which one you want me to go over. And whoever has the most marks, I'm only going to go over those ones. So if you have trouble tonight and you're worried I won't go over it and you have to know the answer, you've got to email me. Okay? All right, there's lots of talking, and it's been a few minutes, so let's try 8. What's the first thing you guys did? Divide by 3, perfect. B over 3 equals 2, t to the 4th. What do I have to do at this point? Log. Log of?
2.
Log base 2. I really wish you would listen and not talk over me. Remember, we use the power rule to bring the t to the 4th in front. Log base 2 of the 2 then gives you 1.
Yep.
Or you can just say that gives you 1. So you just get t to the 4th. If what I said just confused you, same thing. Okay? So then I multiply both sides by 4. And I'm done. T equals 4 log base 2 of b.
You completely lost me. When you put the 4, do you want to put in parentheses?
You can, it doesn't matter. I just stick it in front so I don't have to. Yes?
Are we done now?
Yes. Your homework for tonight is your test review. Okay? Make sure you're doing that test review. Yes. Let me stop my recording and then yes.